but we have time for Dina to give her a presentation on the SPARROW model. And one thing about this presentation is that besides what we're seeing here on this screen, if everything lines up right in the poster session, we're going to have a poster on this. We're going to bring a computer and a monitor where we can do some demos of this model as well. So next talk then is the results, our preliminary results of SPARROW modeling of tributary streams in comparison on the fires.
Good afternoon, everybody. So I'm Dina Saleh. As I'm sitting here listening to my co-workers, I realized I should have given you another talk about Lotus, right? So Lotus is another model that was included in Michelle Stern's presentation. It's I will go through my talk, but once we collect all our water samples and our flow data, we develop a load model to come up with the daily loads for the time period of the study. Those loads will be used in SPARROW, as well as we'll go into the lake model with Alicia, so they can be used for different models in order for model calibration. So I should have had that ready, but I do have a poster this afternoon. I will show you some of those results from the Lotus model if you would like to see more information. So I would like to talk to you today about using SPARROW to look at major loads and the yields of total phosphorus and total nitrogen and Clear Lake watershed, and maybe look at some of the effects of the wildfires and human activities, how they affected those loads in the watershed. So this is a slide you've seen before. Some of the contributors, the green are USGS, blue is UC Davis. So first thing, I will just take care of this acronym right away. SPARROW, the bird, represents a spatially referenced regression on watershed attributes. Basically, it's a mass balance model that simulates water quality responses to climate and land use changes. It helps in understanding factors affecting water quality in the watersheds. It predicts mean annual flux, yields, and concentrations of nutrients in areas that are unmonitored. So unmonitored watersheds and stream beds. It appropriates those loads that we calculate through the model to the upstream, to major nutrient sources in upstream watersheds. It assesses the effect of hydrologic and biogeochemical processes on transport of nutrients in watersheds. The model that we developed for Clear Lake, we developed a total nitrogen model and a total phosphorus model. In order to develop those models, I'm going to jump a slide and go back to it because I want to show you our area. We've seen this model, this figure before many times today. So the small watershed on the left is basically Clear Lake divided by these sub-watersheds. These are called catchments. They're developed by the National Land Use Hydrography Watershed, NHD+. They're in our basin. We have 568 sub-watersheds. The goal of SPARROW at the end of the day is to be able to come up with a load value for each one of those sub-watersheds, even if we don't have any monitoring data or any flow data or measurements there. Like Charlie explained before in the talk before me, for monitoring, we have 8 sites that are with gauging station and water quality samples from USGS. They're in the red dots. And then the 2 red triangles are sites where we sampled for water quality, but we don't have a gauging station. So I actually used output from Michelle Stern's HSPF model to come up to use that flow that was estimated in HSPF to come up with a load value for that site. And then we have 3 long-term DWR sites that has the longer time period of the water quality and the flow data that was used for the load calculation. So with these sites, what we did is we brought those into Lotus, which is a model that will come up with it uses the different set of parameters to come up with the daily concentrations, and then with the flow that we have for that location, but we come up with daily loads. But that's very important to mention. It's only for that site location, so it's not for the whole watershed. And then those sites are used for model calibration. So, but what also, what included with the Lotus loads, you need, in order to develop the SPARROW model, you need a whole bunch of data sets. And these are data sets developed for the watershed. We need basically some physical measurements like drainage area, basin shape, smoke, stream density, stream length, road density. We need land cover data. And for our model, we use the national land cover data set from 2019. We need soil data, bedrock geology, average stream flow data. We used, here I would like to mention that the way we developed this model is basically a steady state decadal model. Well, that means we're taking a time period of almost 10 years. It's from 2016 to 2024, slightly off 10 years. We average all these parameters within that 10-year time period and apply it to the model. So we are actually, when you're looking at if you go in and look at my input file for SPARROW and you look at a certain date, the flow data there is not going to match that date from the measuring and from the sampling time because it's basically the average over that 10-year time period. And then I included in my model, and I'll show you in a minute, the areas that the wildfire in 2017 for the sulfur fire, and the 2018 the Mendocino complex fire. A lot of these data sets were set up, thankfully, by the National SPARROW team. So as Joe mentioned earlier, the USGS developed a program, let's say now it's about 20 years ago, where they developed the National SPARROW model divided over 8 different regions within the country. And they were trying to evaluate sources of total nitrogen, total phosphorus in each of these regions. And Joe and I worked on the 2002 model. After us, there was a 2012 model was developed. A lot of data sets were similar, but they were updated for the 2012 model. That model was developed by Dan Rice from Oregon. And actually, he's my partner on this project. We worked a lot close together to develop a unique application for Clear Lake, because we went through many different efforts in developing a SPARROW model specifically for Clear Lake. But SPARROW in general will work best, like as a lot of models, when you have a variation. So if you have a spatial variation or a time variation, then you'll be able to capture exactly what's going on. We had limited data for calibration, so like 8 years of data for the best scenarios for the DWR sites. And then we had a small watershed. So the small, 568 catchments is not considered a big watershed. So we tried multiple efforts and a local SPARROW model for that one Clear Lake watershed. And unfortunately, we were not able to do that. So what we had to do is we had to work with the National SPARROW team, use their 2012 model, updated with the new data. That's all recent for our time period of the study. And then I will show you a comparison between the results of the 2012 model and this 2019 model that we developed for Clear Lake. Okay, so then I will go back in this. You saw the slide already? Okay, so these are some of my output from the total nitrogen model. So to the right is basically, these are the x-axis is the major watersheds in the Clear Lake. And the y-axis is the load from total nitrogen in kilograms per year. Then I have them divided, but the color screening scheme is for basically the source of that load. In general, for all these watersheds that are delivering flow into Clear Lake, 34% of the total nitrogen, comes from fertilizer and manure application. 30% comes from atmospheric deposition, and then 24% comes from the runoff from the grasslands, and 12% from the urban lands. And these sources vary based on the watersheds, because the watershed composition as far as land use changes, right? Different throughout different watersheds. So you see, like here, Molesworth, the main source of total nitrogen is from the urban runoff. It's the small urban watershed. You have the watersheds like Adobe Creek and Bull Creek. Those are, ag watersheds, so then the agriculture is the main source. This slide shows basically a spatial distribution of the load that was estimated by SPARROW. To the left is basically the same thing that we saw on the bar graph before, as a total, without dividing into the sources, the total nitrogen load in the watershed, right? But I wanted you to look at plot number B. That's the yield. So when you're looking at, you look at, you say, oh, there's like 100 kilograms per year of total nitrogen going into one of these watersheds. It's actually, when you look at it as a yield, then you look at it at a different perspective, because it's only up to 15 kilograms per square kilometer per year going into the lake from the main watersheds. One thing I wanted to mention before, and you guys mentioned, Charlie and Michelle mentioned, like the load to the Clear Lake comes mostly from Middle Creek, Scotts Creek, and Dulce Creek, where it comes up 75% of the load that goes into Clear Lake comes from those three major watersheds. So next, I'll show you total phosphorus. Basically, it's the same outline layout. Plot number B is the load estimated by SPARROW in kilograms per year. Watershed, same thing with Mossworth. The only this is urban. Then here we show that the geologic background, so erosion from geologic backgrounds is the main source in most of these watersheds. Comes up for 35%, and then it also have the load from agriculture, fertilizer application to agricultural lands. And then we have a category here is for manure applied to grazing areas for cows, and then we have the land use. Same thing with the plot A, the sources per watershed varies. The percentage of source varies basically based on the composition or the land use composition of that watershed. Same thing. So this is even more clear. You see the plot B, 3 kilograms per square kilometers per year of phosphorus goes into the lake from these upstream watersheds. That's a maximum, which is, I mean, it's not very much like it. Okay. So then what I wanted to see is if the fire, so here, at this point here, I should have had a slide in the middle here to break this. I wanted to see what's the difference between what Dan Wise did in 2012 and the way he estimated his loads, how his loads compare to what happened in 2019 when we looked at land use variations and after the fires. So this is, you've seen this map before, fire, 2018, 2017, 2018, actually affected 40% of the watershed, mostly in Scotts Creek and Middle Creek, Coles Creek, and then down here in the Burns Creek and Sugars. So I wanted to look at what the fire is doing. So I'll start from the left side with the ranch fire. The three major basins that were affected was Scotts Creek, Clover Creek, and Middle Creek. And you see a lot of the percentages show the percent of the land that was so actually, sorry, this map, this plot is showing the comparison between the 2011 land use data set that was used for the 2012 model and the 2017 land use data set that was used for the 2019 model, my model. So the comparison between the two land use types, you see, because of the, search into the fire, because of after the ranch fire, 10%, more than 100% of the planted land or of the forest land got affected, and mostly like in the Middle Creek and in Clover Creek. And then that will increase the barren land those areas, right? And then in River Fire also did the same thing. It affected Adobe Creek and Scotts Creek, and you see the decrease in forest areas and planted areas, and then the increase in the barren land. This is actually based only on the classifications of the National Planning System. And then Sulphur Creek in 2017 also shows an increase in barren land and a decrease in planted area. So I brought in the new data set from 2017 for land use, and put it into the model with all the other layers. I included the area of Burns land. I updated the fertilizer data. I added in all the different land classifications by national land use data sets. And I wanted to compare between 2012 and 2012 model by Dan Wise and my model for 2019. And this is just a preliminary plot. We're still kind of evaluating again. So the total nitrogen plot shows the percentages is the difference. So what Dan saw in 2012 and what we saw in 2019, how it changed. So you can each watershed, so you'll see like some watersheds, like in Scotts Creek, atmospheric deposition went lower. So it's lower than what Dan estimated in 2012. And I sort back to the loss of forest land. And I mean, we're still evaluating that. Same thing happened with the total nitrogen phosphorus. Certainly, because of the fire, the areas that were affected by the fire were mostly the areas that you see the drastic change. But Scotts Creek, Clover Creek, and Middle Creek, you see the increase in the sources from the decrease from due to changes in the composition of the land use. Plus, also there's an important factor here. You will probably ask why the total phosphorus is showing that from agricultural land there's a difference, an increase in source from agricultural land between 2012 and 2019. That also comes up to a change of amount of application of total phosphorus that was applied between 2011 and 2017 or 2019. The amount of fertilizer manure that was applied in some of these basins. These are preliminary. We still are processing them, but they pretty much I feel comfortable about some of these results. And I appreciate your input if you have any questions about it. So my final slide, basically, this is we really stated this fact very well. Middle Creek, Scotts Creek, and Kelsey Creek account for 75% of the input. Total atmospheric deposition and fertilizer manure application are the main sources of total nitrogen and Clear Lake. And then geologic background, erosion from geologic background is the main source of total phosphorus. So, and then we have the effect of the fire, basically changing the distribution of the land use distribution within the watersheds after the fire, and then affects the sources, that will affect the source of total nitrogen and phosphorus. That's
Well, maybe one or two questions. Anything stands up?
What's the source of the data used to characterize land use?
the national land use data set.
And what is that? Is that satellite? Is it ground truth? Is it what scale is it?
No, I think it started off with satellite, but it is a lot of ground truth as well. So,
And how fine is the detail or in terms of those categories?
It's attachments, yeah.
yeah, so each of those catchments will have like a percent, forested, percent planted. So
By each of those 500 attachments.
No, by the 500 attachments.
Yeah, and then one thing that affected calibration, like Dina said, was we were looking at fertilizer sales and use in Clear Lake Watershed. And over time, they look kind of similar. That one year they kind of dropped, another year they kind of spiked up, which affected their calibration, then they kind of came down. So any agricultural experts that want to talk to us later on, that might know something about that.
So those are the only categories based there. Those are the categories that categorize the land use like forestry, agriculture, urban, barren, and
right. And then there was like there are county level sales, and then there's not a good way to know what's going on with fertilizer applications down to the farm level. So what the group does nationally is to just kind of parse that out with percentages of ag land in each of those small catchments. So that's a little bit coarse, but it's the best that we have.
There's other parameters that are players here, but I don't want to go too deep into the modeling process. There's a delivery variables, there are decay variables you have to account for, right? Your soil composition, all goes into the model as delivery variables and decay variables.
So, what do you call it, the loads versus the yields, so I think I know what the loads are, I can remember. What's the yield?
It's divided, now load divided by the area of the packet.
Is the yield?
Yes. So you're saying 10 kilograms per year generally, but then if you divide it by the area of that catchment, then you're dispersing all that load in that catchment, right? So you're looking at it. Scale.
Did you look at your phosphorus yields per catchment that has illegal cannabis grows back in the day? No, but they bought someone said 0.60 phosphorus that it basically wasn't like that here. They also do because of soil phosphorus. But there was a dip because it was higher enforcement. And then when there was low enforcement, we got a higher level of phosphorus.
Unfortunately, we don't have any access.
Was it that year? Like what year was it that?
Well, it's 2012. So if you look at the fertilizer manure application, it's actually available online. You'll see a dip in 2012 and then goes back in 2017. And it goes to 2017 and 4 years before 2012, 2008. You'll see they're very similar. But 2012, they went down. And so we're thinking maybe we need to talk to somebody with ag. Maybe the plants were like baby plants. They didn't need a lot of fertilizer manure application. They didn't apply as much as the county. Then later they became more mature. They applied a little more. So we're not really sure about this.
I know what that is. I will ask.
Okay.
I know
That'll be one.
in the practice about that.
Okay, so we'll be, I'll be beside my poster later today. And please feel free to come and I can show you some of that data that I was using to develop this.
Thank you. Good job. What's a round of applause for that session?